this lesson's all about threads, but is there only one type of thread? No, there's tons of them. Next question. Does your thread system go to the right hand, or does it go to the left hand? You can have reverse threaded stuff. So when you're looking at a set of plans, and it may have a specification that calls out for a certain type of thread system, there's a lot of information right there. For example, is it coarse? Is it fine thread? What size is it? You know, I can go buy a 1/4 inch bolt, but can you go buy an 1/8 inch bolt? Can you call out an 1/8 inch bolt? You think you can, but good luck going and finding the hardware store, because they're not. I mean, the measurement is there, but that's not what they call them. No, it's actually, they switch to numbers. So you got a 1/4 inch bolt, but then you start going down, I think it's under a number 12 or something, and then they go from like a 12, a 10, an 8, and a 6, which I think a 6 is about an 1/8 inch bolt. So you have to understand that a plan may call for a 1/4 inch bolt, or then it may tell you it's a number 6. And you got to understand the difference between. And when in doubt, you can always thread sizes, or thread size chart. So we got screw size, class size, let's see, here we go. External screw thread sizes. Here we go, look at this. You got a 356, 832s, 1/4 20. What do you think this whole 1/4 20 nonsense is? If I'm gonna go buy a 1/4 inch bolt, what's the 20? Yeah, the threads per inch, the TPI value. That's how many threads we fit in. Does that mean the bolt is only 1 inch long? It just means for however many inches, there's going to be 20 threads for each one of those inches. So if it's 3 inches long, how many threads are in there? 60, right? But look at this. You know, you got this chart, and notice after 1/4, you got 1/4 20, 1/4 20, 1/4 28, and then it jumps down to 10s. I thought there was a 12, but maybe it's just 10s. But a 1032, a 1024, 836, 832. Ever go into a hardware store and actually look at some of this stuff? Sometimes it's hard to pick out. Because if I go and buy a 832 threaded external, what do I have to make sure that I get in terms of the nut? Gotta get the same. Gotta make sure it's, now typically it will be the same. I mean, you could get an 836 threaded. It's not very likely. This is your most common. Your 632s are pretty common. Your 1024, very common. But you'll notice that there's not a standard thread per inch count for all these, right? The 1/4 20s, the 1024s, it all changes. So it's something you have to be aware of when you go to your parts supply. When you're actually looking at a set of plans and you've got to go to your inventory cabinets to pull out the stuff to put it together, you've got to watch this. Because will it work? Will a 836 work with a 832, will an 836 nut work with an 832 bolt? Now, you might get it on there that one time, but that's about it.
And don't leave out metric.
Yeah, let's not forget metric too. Now, fortunately, the metric system is just a little bit better. Makes it a little bit easier for us. Back and forth is a big deal. And again, it depends on your industry that you happen to be in as to whether or not you're going to hit the metric symbols or not. Manufacturing, you're going to be dealing with lots of metric. But if you're dealing with custom manufacturing, you may actually deal up with metric and English. You're dealing with the steel fabrication, you're going to be dealing more with the English. And I call it English, it's really imperial. Actually, I don't even know if that's the correct term. It's like King's English or something. I don't know. Anyway, you can go always down to a number 1. I've never seen a number 1. Number 2s. And I think I have seen a number 4. But keep in mind they're not metric. Yep, go ahead.
We don't want to leave out the grades either.
Well, that is a factor for the designer will specify, actually will omit a lot of stuff that is in a typical call out. The class threading matters to you. And your major diameter, pitch diameter, that kind of stuff, that's not as important to you all on the blueprint side, because your blueprint side is really just to pick out the parts. So whether or not you understand this material, this information here, not as a big deal, unless you actually go to work for a company that makes threads, then it's a big deal. But your diameter, max diameter, that's important because that means you have to drill a hole to receive it for your threading size, or unless you're just drilling a hole to put the bolt down through. Anyway, it doesn't take long to realize you can get this data pretty quick and easy with the internet and have it in your professional portfolio or your own handbook to make it work. Questions so far? All right, let's take a look at the metric thread sizes. Engineering Toolbox is, once again, a great place for this. And look at this. They don't get too specific. They just say nominal size, an M4, an M10. By the way, knowing that an inch is about 25.4 millimeters, which one of these represents a half inch, close to a half-inch thread system, or a half-inch bolt size?
You said they're
half inch. There's 25.4 millimeters per inch in the measurement. So for about an inch, you're looking at about 25 millimeters. So an M12. Your M12 is pretty close. When you get your wrenches out to start torquing on something, an M12 is pretty close to a half inch. So if it looks like a half inch, but you know it's metric, it's probably an M12. Very common number that you'll see in the metric automotive side is the M10. Have dealt with some M6s as well. I was actually taking the cowls out of my car to put some new headlights, or put some new fog lights on not too long ago, some new LEDs, and I was having to get my wrench set out to get everything apart, and that's where they typically ranged. But thread, you'll notice they also don't go into a whole lot of detail in terms of options on pitch. So like an M3, there's the pitch. An M10, there's its pitch. Tell me, why do you think the pitch or the threads per inch change with all these bolt sizes? Why wouldn't we just keep the same number of threads per inch the same for every bolt?
Well, it has to stay in proportion to the...
Okay, proportion to the size. What else? Well, that's basically you can fit more in because you get more length and it affects the strength. So if I got this big old massive bolt, let's say that I have a very low thread per inch. Let's say, for example, and we'll just, let me draw this out separately. Let's say that I have a big long bolt and I have a smaller bolt. And let's say they both have 10 threads per inch. So here's this big bolt that has only 10 threads per inch. And this is a smaller bolt that only has 10 threads per inch, and I'm using force to pull on it. So here I've got this nice solid bolt, but I don't have that many threads. Tell me, where is the strength in the bolt itself when it connects to something else? Is it in just its overall size, or is it the number of threads it can fit in there? More threads, more strength, more resistance to pull. So if this 10 per inch works here, that's great, but if I've got this big bolt, I might as well increase the thread count or decrease, or whatever the case may be, to change the dynamic of the performance of the whole system. So your threads per inch make a difference in terms of strength. Not shearing, because that just cuts the bolt this way, but in pulling power, resistance to force. A little side note there, you don't really need to know that. I just pointed that out. That's why we have a bunch of different systems. So anyway, you can actually check out the fine threads versus coarse threads. They kind of break this down into just different groups and say, you've got your coarse thread metric, you got your fine thread metric. Would you think a machine screw would be a fine thread or a coarse thread? They do like to go with the fine stuff on those. It's not always the case, but just understand there's a difference in terms of how tight you can get things, friction values and everything based on the fine thread versus coarse thread. So a lot of data out there. Your objective really is just to be able to identify it and know what the right thing is to go pick out. Now in the lesson material, you're going to be exposed to the actual rules for call-outs on drawings in terms of the threads, the types, the UNCs, the right hand, left hand, all that good stuff. And of course that will be on assignment or examination materials. Be aware of that one. Questions so far? So it's all about connections, all about putting stuff together, all about ordering the right thing. So good luck in that if you don't have any other questions. All right.